Welcome everyone. Today we are moving our studies on to statics. So we are to study statics today. Alright, so in this video, let's begin with the forces as vectors. Remember, statics deals with forces applied to stationary objects. For instance, if let's assume a body is resting on a surface. Let's assume this body is resting. Alright, so if a body is resting and then you apply a force to it, that steady is what is called the statics. So statics is forces applied to a stationary or a body at rest. Okay, so we are not going to apply forces on the moving objects, alright, or objects in motion. Here they are not in motion. Okay, so we begin with the forces as vectors. The force acting on a body of mass m moving with an acceleration a is given as force is equal to the mass times acceleration. So here always force is given as mass times acceleration. Alright, so mass is in is measured in kilogram and acceleration is in meter per second squared. So force is a vector quantity and the SI unit is Newton. Now in the representation of forces, forces can be represented in the magnitude and the direction form. For instance, if you have let's say a force of F Newton, alright, and then you represent or you show the direction of it. Alright, so this representation is a force and its direction, so it can be represented as the magnitude and its direction form. And also we also have the column form. That is, you can have A, B here, or Newton, the column form of forces. And also the Cartesian coordinate form, that is AI plus BJ, or normally you will see XI plus YJ, where X is the unit vector along the I is the unit vector along the X axis and J is the unit vector along the Y axis. Alright, so that is what is being explained here, where F is the magnitude of the force and this theta is the direction. When forces are given in this form, it can be expressed in the column or component form. That is, there is the column form AB here, or the Cartesian coordinate form, which is SI plus YJ, where I and J are the unit vectors in the X and Y directions respectively. Okay, so those are the gist about the forces as a vector. So let's now move into the resolution of forces. Resolution of forces. Let's assume you have a body here, and then a force is acted on it. A force acts on it in this direction. Alright, now because the force is acting on the X and Y directions, can have this, so we need to resolve this force here in terms of the X axis and also the Y axis. Alright, so if we are able to resolve those forces, that falls into it. Then we have resoluted that particular force. For instance, this is the given what force, and then the angle from the North Pole is what our theta here. So if you want to resolute or this force F along the y-axis, remember this is theta here, so this becomes our adjacent. This is the adjacent, the opposite, and not the hypotenuse. So if we have adjacent here, then it means we can use the trig function, which is the cosine, right? Well, cos theta is equal to, we have what, adjacent over hypotenuse. That means y over what, the hypotenuse, which is f. So in solving, y will be equal to f cos theta, and which is represented here, f cos or theta. Alright, also if we are to resolute this on the horizontal axis or on the x-axis, remember, because this is the opposite side, we take sine theta, which is opposite over what, hypotenuse. Alright, so we have x over f. So our x-axis will be f sine theta. Alright, and then this is what we have here. So it means that on the x-axis, if we are having a directional vector here and we want to change it into the s column form, we multiply the force by the sine of the angle. And also, if we are to resolute it vertically, then we have to multiply the force by the cosine of what, the given angle. Alright, so it means we can have a new representation as the force to be on the x-axis. We have f sine theta, and then on the y-axis we have f cos theta. Alright, so with this, let's solve the given examples. The examples here, we are to express the following as a column vectors. So f1 is equal to 10 Newton and then 30 degrees. 10 Newton, 30 what degrees. Alright, so we have f1, which is 10 Newton, that's the magnitude of the force, and then its angle 30 degrees. Alright, so definitely we are based on the given what formula we have here, should be f sine or theta and then f cos theta. Alright, and this is going to give us, this is the f, the magnitude of the force, that is 10 sine 30, and then we have 10 cos 30 here. Alright, and then if you use your calculator to key in 10 sine 30, remember sine 30 is 1/2, but let's still use the calculator. We have the sine symbol here, so 10 sine 30, then you close it. Alright, so this is 5. That means we have 5 here, and also the last one, 10 cos 30. Alright, and this is also 5 roots 3. Okay, so in column form we have represented this for us as that. Alright, so we can use this format to solve for F2 equals 20 Newton 240 degrees, and then for F3 as well as what F4. So you have to try that on your own. Alright, and then example 2 is nothing different. Given that P is equal to 8 Newton 30 degrees, express P in the form AI plus what BJ, where A and B are what scalars. That means we are to express it in the form of what Cartesian, or in Cartesian form. Alright, so it's so simple. Let's see here. Now if you have a column form, let's say A, B, in its Cartesian form is just AI plus what BJ, as this is the x direction and then the y direction. It's so simple. So if you work for this from here, P is giving us 8 Newton and then 30 degrees. Alright, so what we do is, we in column form we have F sine theta, F cos theta, of which we are aware of it. So 8 sine 30 here, and then 8 cos 30. Alright, so here use your calculator. Simple. You have the sine here, sine 8 sine what 8 sine 30. Alright, so we have 4, that is 4 here, and then the next one is 8 cos 30. Alright, and that too is 4 root 3. Alright, so to represent it in the form of this is our A and then B. So we have 4i plus 4 root 3j. Simple as that. So I will end this video here. Thank you for watching. This is the first part of the statics, and on the next video we are going to move on to the resultant vectors. Alright, resultant of what vectors. So thank you for watching, and don't forget to share this video to your friends to also have the benefit of it. Remember, together we build. Bye bye.